By now we should all be familiar with spanning tree. In a spanning tree topology, quite often redundant links are blocked in order to avoid a spanning tree loop. What vPC does, in short, is allow us to use all the bandwidth that we have available for our links. It does this by making the top two switches look like a single switch or a virtual switch instead of two separate physical switches. This way, the downstream switches think they're connecting to the same device, and therefore there's no loop. When we talk about vPC, or virtual port channel, there is some terminology that we must become familiar with. First of all, the switches involved in a vPC configuration are called vPC peers. Next are the vPC member ports. The vPC member ports are one of a set of ports or port channels that form a vPC. The vPC is a combined port channel between the vPC peers and the downstream device. The vPC peer link is a link that is used to synchronize state between the vPC peer devices. Data also traverses this link in the event of a failure. The vPC peer keep alive link is another very important link. It is used to detect the status of vPC peer devices. Cisco Fabric Services is a protocol used for state synchronization and configuration validation between vPC peer devices. The CFS protocol is transferred over the vPC peer link. vPC VLANs are VLANs that are carried over the peer link and carried over the member ports. Non-vPC VLANs should not be carried over the peer link. vPC orphan ports are singly connected hosts that are not using vPCs that are connected to the switch but are still using VLANs that are used in other vPC configurations. There are certain best practices that must be followed when you implement vPCs on a Nexus device. The first one is to utilize diverse 10 gig modules to form the vPC peer link. If you're not using a modular switch, you also might try to use diverse port groups on the fixed configuration switch for vPC peer link members. These links must either be M or F and can be mixed on each side. These links can also be on a Nexus 5000 or a 6000 that do not have M or F modules. Once again, it is recommended to have module diversity and not deploy this on a single 10 gig module, even though it is supported. Another best practice would be to implement physical vPC peer link ports in dedicated rate mode. Some Nexus 7000 modules have the ability to share port ASICs across multiple ports. This gives you quite a bit of scalability at the sacrifice of performance. In this case, we recommend using the highest performing dedicated rate mode for the vPC peer link ports. We also recommend using a dedicated link for the vPC peer keep alive and assigning it to a separate VRF. This keeps the routing of that network separate from other things that may go on in your environment. If you can't use a dedicated link for your vPC peer keep alive and you have to use management 0, it should be connected to an out-of-band management network. Back-to-back management 0 connections should only be used in a single supervisor implementation or on a device like a Nexus 5K or possibly even a 6K. And as a final note, absolutely do not use an SVI interface going over the vPC peer link as a vPC keep alive link. These links should be independent of each other. Please take some time and become very familiar with the vPC terminology. This feature is very valuable in your Nexus environment. Please join me for the next lesson, understanding how a VPC functions.